I wanted to give you some feedback on problem number 11 on the first exam because I saw a lot of Boolean algebra on this problem, and if you do that correctly it all works out. But the point of this type of bubble notation is to represent the circuit that's built using only NAND gates. I'm sorry, in this case, it's a combination of gates. All right, it's not only NAND gates, but it's using different types of gates. Some of them are NANDs, some of them are NORs, but, you know, as humans, we don't think very well in NANDs and NORs, and so this notation that we do with adding bubbles means that we don't have to think too much about that. We don't have to do the De Morgans in the Boolean algebra. We can represent this more directly. Okay, so my thought process on this is that when you take the input to every gate, all right, and you look at what happens with the bubbles. Okay, so when I take X, all right, I'm looking at X, I hit the bubble, so I know on the output side there's going to be an X bar, all right, and then with Y, the bubbles cancel, and so the shape of the gate is OR. All right, and so from there, I would just write the shape, X bar or Y, okay? And so that's the input at this point here in the circuit. All right, next the bubbles cancel, and so on the output, I get X bar or Y. All right, and it's a shape distinctive thing, so this is an AND shape for the function, okay? And then I'm ready to take a look at the next input. All right, so in the next input, I have W. W hits an inverter, so that would be W bar. The shape is OR. All right, the bubbles cancel on the Z. So this would be W bar or Z. The bubbles cancel here. This goes through the AND gate as W bar or Z. All right, so that's my answer. It's X bar or Y ANDed with W bar or Z. And that's what I wanted. You know, if you put some Boolean manipulation of that, you're missing the point of the problem. The point is we can represent circuits that use NAND and NOR without going into the Boolean sort of hard way of thinking of things using NANDs and NORs. And one final point is I want to make sure you understand that when I'm drawing this arrow to the AND gate, or AND, I'm talking about just the AND function, okay? When I include the inputs and the outputs, so if you include this whole thing that's in the circle here, I have bubbles on the inputs, I have an AND function, which, you know, it would give me X bar ANDed with Y bar, okay? And if I took a look at that and did a NOR, okay, then NOR is X or Y bar, and I can use De Morgans to show that this is the same thing as X bar and Y bar. Okay, so my point is, the thing in the circle is a NOR gate, all right, and correspondingly, if I take a look at this gate with the bubbles on the input and the function being an OR, this is a NAND gate. So that's just one follow-on to this problem.